Yeah, question 13, which compound cannot be oxidized by acid or potassium dichromate solution, but does react with sodium metal? So what is it telling me? It is telling me that with sodium metal, this thing can react as an acid, but it cannot be oxidized by a strong oxidizing agent. So because all of them are alcohols, we know that only tertiary alcohols cannot be oxidized, but all alcohols can act as acids with the sodium metal. Weak acids, but still they act as acids. तो इसका मतलब हुआ yeah. Which one is a tertiary alcohol? Because those are the ones that can't be further oxidized.
So is it A?
It is a yes. So वही answer है हमारा. All right, let's try this. Which row correctly shows a primary, secondary, and tertiary alcohol? So come on, ये बहुत आसान है. You guys do it. बताओ. Alcohol is anything with OH, right?
Yes.
No.
What do you mean?
COH. There's a OH over there.
Only OH.
Yes. So because of that, we have this is an alcohol, this is an alcohol, this is an alcohol, and this is an alcohol. Okay. So they're all primary alcohols, right? Because OH is attached to the carbon that is attached to a primary carbon. So yes, primary carbon, primary carbon, primary carbon, and primary carbon. Yes. So ये सारी हो सकती हैं. Secondary alcohol is basically an alcohol. OH is attached to a secondary carbon. Secondary carbon, secondary carbon, primary carbon, primary carbon. So ये तो नहीं हो सकता. And this is secondary carbon. So A, C और D में से C नहीं हो सकता. A, B और D में से हो सकता. And then हमारे पास tertiary. Tertiary is OH is attached to the carbon that's a tertiary carbon. So बताओ कौन सा है? There's only one option.
There's C.
No. C is not even a secondary carbon. So how could it be correct for the third one? This is a primary carbon. Diol hai, but they're both primary. And this one is carbon. You have to look at this carbon. The carbon is primary. This carbon, which is quaternary or is not attached to any OH. But all the OH are joined to carbons that are primary. This is the one because OH is attached to a carbon which is joined with 3 other carbons, tertiary carbon. Okay?
Okay.
Malic acid is found in apples. Okay, so we have 2 carboxylic group and 1 OH group. Which agent will react with all 3 OH groups present in malic acid molecule? So, what is something that both acids and alcohol react with?
Sir, what do you mean?
What is something that reacts with both acids and alcohols? दोनों के साथ reaction होता है उसका. It's a reactive metal. Because with the reactive metal, both acids and alcohol react as acids. So acid ने तो करना ही है, but alcohol भी करेगा. And because of that, it's going to be what option? Come on, इतना आसान है. रिएक्टिव मेटल कौन सा है यहाँ पे?
C.
C, sodium. Yes, that's right. Write this question. So this is basically combining the knowledge of alkenes that we have and of course the alcohol that you have. So let's see. KMNO4 क्या करता है?
It's an oxidizing agent.
Yeah, it's an oxidizing agent. So with an alcohol, it's going to oxidize it. Primary will convert to ethanol, or sorry, aldehyde, and secondary will convert to ketone, but tertiary won't. And what does KMNO4, cold KMNO4, do to alkenes? Cold KMNO4 makes diol. Both the carbons are attached to a diol. ठीक है, एक दोनों कार्बन पे एक OH आ जाता है, right?
Yes.
ठीक है. What does warm KMNO4 do? या hot KMNO4? It breaks the double bond. When it breaks the double bond, you can then further oxidize those branches अगर वहां पे ऑप्शन हो तो. So अगर डबल बॉन्ड है, प्राइमरी अल्कोहल है, तो वो तो कार्बन डाइऑक्साइड में कन्वर्ट हो जाएगा. अगर डबल बॉन्ड है, सेकेंडरी अल्कोहल है, it will be converted to aldehyde or a ketone. Sorry, it will be converted to aldehyde. And tertiary है, तो it will be converted to ketone. That's how the method works. The bond breaks at hot concentrated KMNO4 will convert it to aldehyde, carbon dioxide, or ketones. And of course, aldehydes are then further oxidized. So यहाँ पे देखते हैं होगा क्या. Under appropriate condition, acidified KMNO4 can be used to break apart carbon-carbon double bond. That means we need hot and concentrated. So it's going to be C or D. After these bonds have been broken, where will the bonds break? It will break here, 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 and here. Okay? All right. Under which conditions is acidified? And obviously further oxidation होनी है उसकी. So let's see. यहाँ से जब breakdown होगा, this is a tertiary carbon, this is a tertiary carbon, they will both make ketone. Because a tertiary carbon in a double bond converts to ketones. Secondary carbon in a double bond converts to aldehyde. And tertiary carbon, sorry, primary carbon, carbon dioxide. अच्छा, यहाँ पे ketone बनेंगे, ठीक है? यहाँ पे this is a secondary carbon aldehyde बनेगा, which will then convert to carboxylic acid. This is a secondary carbon aldehyde बनेगा, convert to carboxylic acid. This is a tertiary carbon converts to ketone. Secondary carbon, carboxylic acid, carboxylic acid, carboxylic acid, ketone, carboxylic acid, carboxylic acid. So you're getting ketones and carboxylic acids at hot concentrated KMNO4. So the answer is D. You understand?
Yes, sir.
Perfect. X, Y, and Z are three isomeric alcohols. Okay. What kind of isomers are these? Structural, functional group, branch, cis trans. कौन से वाले हैं? These are all structural isomers because OH is present at the first carbon. Now it is present at the third carbon. Now it is present at the third carbon, but this has a branch as well. So this is the second carbon now. So basically structural isomers हैं. Two or more of these alcohols react with mild oxidizing agents. Primary alcohol होगा. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers. When do you get a pair of cis-trans isomers when dehydrated? When you get a double bond which is attached, the carbons are attached to two different groups. So OH and H remove करने हैं, but carbons are attached to two different groups. ठीक है? Will give a pair of secondary carbon with formula C5H10. अच्छा, तो इन सब में कार्बन कितने हैं? 5 हैं. Okay. Yeah, they all have C5. But where will it be giving us a cis trans isomer? Okay, let's see. So mild oxidizing agent के साथ कौन सा react करता है? बताएं इन दोनों में से. Which will react with mild oxidizing agent? Come on, रिवाइज नहीं किया है मुझे लग रहा है. महर आपने रिवाइज नहीं किया.
Sir, is
Why?
mild the same as weak?
I'm sorry.
Is mild the same as weak?
Yeah. देखते हैं ना कौन सा ऑक्सीडाइज होगा. ये ऑक्सीडाइज होगा, यस. ये ऑक्सीडाइज होगा, यस. ये ऑक्सीडाइज होगा, नहीं. क्यों नहीं होगा? टर्शियरी कार्बन है. सिस ट्रांस आइसोमर्स देखते हैं. We have to remove OH and H from the adjacent carbon and OH from wherever it is. So अब देखते हैं यहां से प्राइमरी कार्बन है. When I remove this OH and this H, so मेरे पास cis trans isomers बनेंगे? नहीं बन सकते. Why? Because once I remove OH and I remove H there, तो मेरे पास क्या चीज बनती? ये पूरा मैं इसको R बोल रहा हूँ. R ऐसे कैसे रहेगा? This carbon will lose a hydrogen. That carbon will lose OH. So यहाँ पे डबल बॉन्ड है. दो डिफरेंट ग्रुप्स हैं? नहीं. You have CH2. The carbon is attached to two same groups. That is why this will not make cis trans isomers. Okay, let's look at the second one. I remove this OH, and obviously I can remove H from either this one or this one. And in this case, I will get cis trans isomers. Why? Okay, let me call this. This is R. So I have RCH, CH, CH2, CH3. This is cis trans isomers because this carbon is attached to two different groups, hydrogen and R. This carbon is attached to two different groups, hydrogen and this carbon. Two different groups attached, ठीक है, and double bond भी है. यहाँ पे double bond है इनके बीच में. So definitely this is going to be the answer. Okay. Okay. Next one. This is OH. If we remove this one, there is no chance. There is one chance कि ये वाला हमें हाइड्रोजन देगा. ठीक है. Okay. So यहाँ पर OH remove होया, but then this carbon is attached to both methyl groups. So cis trans isomers नहीं बनने लगे. Okay. And because of that, we will not get cis trans isomers here. Now the other option is I remove OH from here and H from one of these. But then again, whichever I remove it from, that has CH2 attached to it. So this will also not give me cis trans. So oxidize होगा, yes. Cis trans होगा, नहीं. तो हमारे पास ये सारी सिचुएशन आ गई है. So now reacts with mild oxidizing agent, that's going to be X and Y, and give cis trans isomers, that's Y only. So Y only and X and Y. C. Clear?
Yes, sir.
Okay. Propan 2-ol undergoes many reactions which row is correct. All right. Propan 2-ol है, secondary alcohol है, we know this. Isocyanated KMNO4 डाला, product is an aldehyde. नहीं. Propan 2-ol है भाई. CH3CHOH CH3. That's propan 2-ol. Okay, so this will convert to CH3COCH3, not this thing. Ketone बनना चाहिए. Chlorine, when you add chlorine, concentrated chlorine add कर रहे हैं हम इसमें ज़्यादा सारी, so it will displace the OH. Will it? और साथ में HCl बनाएगी. करेगी? Substitution होगी ना? या नहीं होगी? होगी भाई. क्लोरीन ऐड कर रहे हो, लेकिन सब्स्टिट्यूशन किसकी होगी? हाइड्रोजन की. फ्री रेडिकल सब्स्टिट्यूशन, नॉट OH की सब्स्टिट्यूशन. प्योर क्लोरीन नहीं कर सकता है, because pure chlorine will not provide a nucleophile that can displace OH. This will be free radical substitution. So I can get a chlorine here by removing H, or here, or even here, but I will not be able to take the OH out. ये OH नहीं जाएगा because OH will not be substituted. It's a nucleophilic substitution that must occur. Chlorine itself can't do it. You need something to provide a nucleophile. HCl से nucleophile आता है, यहाँ से नहीं आता है. सोडियम क्लोराइड से न्यूक्लियोफाइल आता है, खाली क्लोरीन से नहीं आता है. ओके, सो ये भी नहीं हो सकता. Concentrated sulfuric acid, and that's a rehydrating agent. Will it remove H and OH? Yes. So that means it will remove OH from this and got hydrogen from either one side. So वहां पे CH2 रह जाएगा. So CH2, CH, CH3. And yeah, that is correct. Okay. Last one, methanoic acid. Acid alcohol के साथ मिलके क्या बनाता है?
Ester.
What do I? Ester. Yes. So we will get an ester here. This one right now is not the ester that we'll get, because this one is assuming that we are connecting the alcohol. This is the alcohol part, connecting it at the first carbon. Again, this is secondary alcohol. First carbon से join नहीं हो सकता. Okay.
Okay.
Lactide is an intermediate in the manufacture of synthetic fiber. Okay, which compound on heating with an acid catalyst can produce lactide? Okay, what kind of functional group does lactide have?
Is it an aldehyde?
No, it has C double O group in it.
So is it
This is
ester?
C double O group. This is ester. Yes, very good. So judging by that, I also see some symmetry here. Those symmetric groups are मेरे पास. I can give them a different color to distinguish. Okay. So these are two different groups that are joined together. Okay. अब क्या हो रहा है? Which compound on heating with an acid catalyst can produce lactide? How do you create alcohols? How do you create esters? You create esters. ये ester ही तो है. So ये जो इसका जिससे ये join होया है ना, this thing, this must have been converted to what? Ester. अब ester में कैसे convert होती है? जब आपके पास this bit is attached to OH and that bit is attached to CWH, and that is the thing that has caused it to become what it is. Do you understand?
Sir, can you explain this again?
Sure. Identify the structure of an ester. We know in ester you have C double O bond. This part is attached to something coming from the alcohol, and this part is attached to something coming from the carboxylic acid. If I look at this one, this unit that is making lactide, then I can clearly see that it has an ester linkage, and if I break the ester linkage, this is what I get. Sorry, that is not there. This is what I get. I just broke it. That's what the acid will do. It will break it down, break down the ester linkage. And when I break the ester linkage, what do I get? I get OH on one side, which will be this one, and H from the other side, which will be this one. So judging by that, I can clearly see that this is 1, 2, 3 carbons in the long chain. So prop and propanoic acid, because COOH here. This is propanoic acid with OH group on the second one. So 2-hydroxy propanoic acid. Does that make sense?
Yes, sir.
Good. Okay, a sample of 2.3 gram alcohol was mixed with an excess of caie. The reaction mixture was then boiled under reflux for 1 hour, so that obviously goes to completion. The required organic product was then collected by distillation. So acid banaya और collect कर लिया. The yield was 60%. What mass of product was collected? So they're basically saying that we took ethanol, we oxidized it, gave it enough time, but obviously कितना time हुए चाहिए हमें नहीं पता. Now 2.3 gram is completely oxidized to ethanoic acid. Ideally, we should be getting what? कितना ethanoic acid मिलना चाहिए? हमें उसके moles को देखना होगा, right? So ethanoic acid कितना होता है? This is oxidized to this, okay. Of course, water is a byproduct or something. अब यहाँ पर mole ratio is 1:1. So the MR of ethanoic acid is 32 plus 24 plus 60 grams. So 1 mole should produce 60 grams, which means 1 mole of this thing is 46 grams. 46 grams should produce 60 grams ethanoic acid, but 2.3 will produce X. So judging by this, I can see that 60 ka half of the 3, and I should be getting 3 grams. Right? 30 hota hai na uska half. 46 ka half है 23 और उसका divided by 10. I'm just doing the calculation. You can use the calculator. So this is going to be 3 grams. Ideally, I should be getting 3 grams. But I did not get that. I got 60% of that, which is going to be what? 1.8.
Sir, how do you know that 46 gives you 60?
I look at the equation. Ethanol 1 mole will provide 1 mole ethanoic acid. MR of ethanol is 46 grams, and for ethanoic acid is 60. So 1:1 ratio, so 46 gram will give me 60 grams. Clear?
Okay.
This is basic stoichiometry. Yield का question है. I think second one is being repeated, so उसको skip कर रहे हैं. Compound X is a single pure optical isomer. Okay, X is heated with an excess of concentrated sulfuric acid. Only one organic product is formed. Compound X is single pure optical isomer. Optical isomer का क्या मतलब होता? What does it mean? Optical isomer. It means there is a chiral center. It means that there is a carbon attached to 4 different groups. Okay, that's what it means. Okay. X is heated with excess concentrated sulfuric acid. Only one organic product is formed. So, अब जब इसमें से किसी भी चीज को मैं sulfuric acid से react करूंगा, and this is concentrated sulfuric acid, excess में it means it's going to dehydrate it. When it dehydrates, it's going to remove the OH. When it removes the OH, then I must get one organic product, no other thing. कोई isomer और नहीं बन सकता है. Let's see. सबसे पहले देख लेते हैं X में chiral center होना चाहिए था. Which of A, B, C, and D have chiral centers? Tell me.
There's C.
C. This one?
Yes.
How about this one? That's
Yeah, but
also
doesn't
chiral.
this one just have 3? Like, isn't it just attached to 3 other?
No, there's a hydrogen that's not shown. Carbon has to have 4 bonds anyway, and hydrogen is the filler.
Okay.
Okay, D has a chiral center. Where is it?
Like
It's
next
this
to
one.
CH2OH.
Yeah, next to CH2OH. And this one as well. This is also chiral. Does B have a chiral center? Yes, B has this one as well as this one. And this one also has a chiral center. One.
Sir, in D, isn't the one next to OH also a chiral center?
In B, the one next to OH. Yeah, that's also chiral. And this is also chiral. So chiral centers तो इन सब में है. अब वो कहते हैं कि उसको जब हम remove करते हैं, only one organic product is formed. The other is obviously going to be water. So अब जरा हम OH को remove करते हैं. If I remove OH from here, then do I have any options? I have an option of removing hydrogen from this one, giving me a double bond, which means that I could get cis-trans isomerism. Remember that in rings, you can get cis-trans isomerism depending on whether one hydrogen is above and one is below plane of ring के साथ. Introduction to organic chemistry. पहला topic जब हमने organic और isomers को discuss किया था. We talked about how you can have cis-trans isomers in alkenes, in straight chain compounds, or in rings because of the plane of the ring. So this one, A, can give me that option because with A, I can remove OH from here, but hydrogen from here or here, which causes a lot of different isomers to be made. In B, I can remove OH from here and hydrogen from this one. There is no option of removing hydrogen. No, wait a minute. There is an option. Hydrogen can also be removed from here. ये तो बात फिर खत्म होगी, दो isomers बन सकते हैं. In this one, I can remove OH from here and hydrogen from this one or this one. Again, I have multiple options. In this one, I'll have to remove OH from here, which means there's only one option of removing hydrogen, which is this carbon. So this is not going to give me any other isomers. So this is it. D is the answer. Do you understand this?
Sir, can you explain again?
So I'm removing OH and H from the other adjacent carbon. And because I need just one organic compound, that means I can only have one option of removing hydrogen. If I get multiple options of carbons where I can remove hydrogen from, that will obviously lead to isomerization. And they're saying only one organic product is formed, you can't have isomers.
But sir, in D, if you remove it, can you remove the hydrogen from two carbons?
I'm sorry?
In D, if you can you remove the hydrogen from two different carbons?
I don't see an option.
Like, I don't get why it's D.
Because let's see where we can remove OH from. There's only one option. We can only remove it from here. But the carbon that removes hydrogen, that gives hydrogen, should be the one adjacent to that. And being primary, there's only one option of the other carbon where you can remove hydrogen from. In secondary carbon, in secondary alcohols, there can be options. For example, if you look at B, you can remove OH from here, but hydrogen you can remove from this carbon or this carbon. You have two options. But in D, because it's a primary alcohol, you only have one option from where you remove hydrogen, which is this one, the one adjacent to it, which obviously means there's no other isomer going to be made.
Okay.
This one is repeated. Which statement about butane-1-ol, butane-2-ol, and 2-methyl-butanol is not correct? Okay, one is primary alcohol, butane-1-ol. So 1, 2, 3, 4, and there's OH. 1, 2, 3, 4. Sorry. 1, 2, 3, 4. OH, butane-2-ol, and 2-methyl-butane-2-ol. So 1, 2, 3, 4, OH, and then 2-methyl-butane-2-ol. So this is methyl as well. Okay, which option is not correct? They already act with methanoic acid to form an ester. Tell me, do they? Tertiary carbons, do they make esters? They can't. Okay, they already act with sodium. फिर वही
So why
बात,
can't
tertiary
tertiary carbons make esters?
Why can't they make esters? I never really thought about it. Let's see. Methanoic acid है, तो technically तो ये बन रहा है. So what's the problem? Let's see. I'll look it up. देखता हूँ इसको. Okay, they all be dehydrated form an alkene. They can all be dehydrated. No, not all can be hydrated. ये हो सकता है. Yes, this will go. This hydrogen from here will go. This will go. Hydrogen from here or here will go. This will go, but कहाँ से जाएगी हाइड्रोजन? यहाँ से जा सकती है, यहाँ से जा सकती है, जा सकती है. तो सही बात है. नहीं, सही बात है. This is also correct. ये भी हो रहा है, ये भी हो रहा है, ये भी हो रहा है. Oh, you're right. Tertiary carbons can make ester. ये बन तो रहा है. So this is correct. This is correct. This is correct. They can be all be oxidized to carbonyl compound. Tertiary carbons can't be oxidized. So, oh, I'm sorry, I got confused. वो question में बोल रहा है कि not correct. So this is not correct. Yes. So this is correct. Correct.
Carbonyl compounds are aldehydes.
Carbonyl compounds are the compounds with this thing.
Isn't this
so
ketone?
Aldehydes, ketones, carboxylic acids, esters, all of them are carbonyls. ठीक है?
ठीक है sir.
I'm sorry about that other comment about tertiary carbons. That wasn't correct. 2,3-dimethyl-pentuene, okay, is treated with cold dilute KMnO4. What does a cold dilute KMnO4 do to this thing?
Makes diols.
Very good. It makes diol on where the double bond is. The product of this reaction, the diol, is treated with excess concentrated sulfuric acid. अब उससे क्या होगा? It will remove OH and H, giving us new double bonds, right? Those double bonds can be on the adjacent carbon. So दो नई double bonds बनेंगी. Okay. What is the name of one of the isomeric hydrocarbons? So it's easy. First of all, break the double bond. You have, what do you have? So you have C double bond this, okay? And on one side I have a methyl, CH3. On the other side I have CH2, CH3. On this side I have CH3, and on this side I also have CH3. Okay, now this thing broke off, and this gave me an OH here and OH here. Now that also went away, and now it must take one hydrogen away from each adjacent carbon. So what are the candidates? We could either remove hydrogen from here or here, and in both cases it will be the same thing. So you're going to get a double bond here, or you're going to get a double bond here. ठीक है, दोनों में से एक बन जाएगी. Okay, so that's one thing, which will obviously give us a branch on this carbon. There will be a methyl on the second carbon. Okay, remember this. There's going to be a methyl on the second carbon because chain यहाँ से शुरू होगी ना. अगर ये वाला hydrogen जाता है तो chain यहाँ से शुरू होगी, which means the second carbon has a methyl group. Okay, so I'm definitely going to get a methyl group. तो 2 methyl तो होगा. अच्छा, अब देखते हैं आगे. Will I get cis trans isomers? This one, if I give hydrogen away, then I am not going to get any cis trans isomers over here because this is CH2. No cis trans isomers possible. Okay, what about the other side? If I remove OH from this one, the hydrogen has to go away from somewhere. So अगर यहाँ से जाता है, so that will also not give me cis trans isomers. तो ये भी नहीं हो सकता. But अगर यहाँ से जाता है, so this will be left over as CH. So there'll be a double bond here. This will be CH. And in this case, you will get a methyl on the third carbon. This is the third carbon. This is first, second, third. Third has methyl. Second नहीं, fourth. तो मैं दूसरी साइड से आ जाता हूँ ना. तो मैं दूसरी साइड से देख लेता हूँ. So I could get a double bond here. So ये hydrogen यहाँ से इन दोनों में से एक जाएगा. I'll get a double bond here. So CH2, this is a methyl. So that means Methyl on the second one, 1, 2, 3, 4, 5. Second one has a methyl, third one has a methyl, 2, 3 dimethyl. Okay, हो गया. 2, 3 dimethyl किधर है? अच्छा, काफी है. Double bond is on the first carbon and on the third. So 2, 3 dimethyl, pent 1, 3 diene. So इन दोनों में से देखना है. अब हमने देखना है सिस ट्रांस आइसोमर हो रहा है कि नहीं हो रहा. हो रहा है because cis trans isomers यहाँ पे बन रहे हैं. This is attached to 2 different groups and this is also attached to 2 different groups. So judging by that, B is the answer.
Wait, sir, I don't understand. And why can't it be C?
Because 1,4 diene नहीं है. 1,4 का मतलब है fourth carbon पे double bond आई. But fourth और fifth पे तो हो नहीं सकता because fourth never got the OH. OH was on the second one and on the third one, which means double bond अगर बनेगी तो first के साथ बनेगी और fourth के साथ बनेगी. Fifth वहां पे आ नहीं रहा.
तो सर
इसी को करने का एक और तरीका भी है.
तो why can't it be
Let's
C?
try that one. Let's try this one. Let's ignore all the hydrogens and just focus on the carbons. Judging by this thing, I have a double bond here. I have one carbon here, one carbon here. Okay, I have one carbon here, which is then attached to another carbon here. I'm ignoring all the hydrogen. अच्छा जी, सारा कुछ हो गया. Double bond OH उड़ गया और चला गया तो double bond कहाँ आ सकती है? What are the possible places? Either double bond will be here or here. So in either case, it's going to be on the first carbon. ठीक है? मतलब इधर से आएगा तो इधर double bond है, इधर से आएगा तो इधर double bond है. Okay. Then the second double bond can either be here or here. So in that case, the double bond is on the third carbon. So judging if you go from here, then it is the first carbon that has a double bond and third carbon that has a double bond. Okay. अगर यहाँ से भी आता है तो first will have a double bond or the third will have a double bond. So I'm definitely going to go for 1, 3 diene. But whether I'll get cis trans isomers or not, वो मैंने कार्बन वाले इस केस में देख चुका हूँ. Do you get it?
Sir, can you explain how it's cis trans?
How it's cis trans? Okay. So let's put the hydrogen back. So I got, let's suppose this is 1, 3 diene, ना? इस तरह से हो गया. अब इधर इसके साथ हाइड्रोजन है और इधर कार्बन है और इसके साथ इधर कार्बन है और इधर इसके दोनों साइड्स पे हाइड्रोजन है. So this one has hydrogen on both sides. So this is not going to give us cis trans. But this one has hydrogen and methyl, and this one has methyl and this whole thing. So this carbon is attached to 2 different groups. This carbon is attached to 2 different groups. Cis trans बनेगा. Do you get it?
Sir, do the groups have to be like the same on both carbons?
Do the groups have to be the same on both carbons? What do you mean groups?
Like if there's CH3 on one, shouldn't there be CH3 on the other? And like hydrogen and hydrogen.
No, you can have cis trans isomerism like this. I have 2 double bond things, totally different things, A, B, C, D. That's one option. I could also have A, B, D, C. Cis trans isomers बन गए. Cis trans isomerism exists because of restricted rotation of double bond. So as long as you are not able to rotate the thing, or you have 2 different groups, वो बन जाएगा. दोनों साइड्स पे 4 के 4 ग्रुप्स डिफरेंट हो सकते हैं.
Okay.
Many but not all organic reactions need to be heated before a reaction occurs. Okay. Which reaction occurs quickly at room temperature? G. ये तो बहुत आसान है. Which one reacts really quickly? ये पहला ही बहुत तेज है. PCl5 is very reactive. We don't need to heat it. ये हमने कल किया था. Produces HCl, BOCl3, वो सारा. So yeah, this is good. This is good. A answer. Nucleophilic substitution. That's the reaction. Okay, what are the only structures found when butane 2-ol is heated with concentrated sulfuric acid? Butane 2-ol है, हमने बना लेते हैं उसको. So 1, 2, 3, 4. This is OH. Now I'm removing OH Okay, and I'm removing hydrogen from another one, so we're going to give it a double bond. Either the double bond can come here or the double bond can come here. So two different isomers possible. अच्छा, अब देखते हैं वो कह रहा है कि इन दोनों में से कौन सा वाला बनेगा. Either on the first carbon or on the second carbon you can have a double bond. Okay, देखेंगे. तो A does seem right, except A के अंदर this product, this one can give cis trans isomers, and because of that I'll get three different isomers. A does seem right because if I have the blue double bond, then it is this one, and if I have the green double bond, then I have this one. But this one can give me cis trans isomerism because methyl and methyl. So this one is trans right now. I will also get a cis, so iska cis utha lete hain. So this is the cis, this is the trans, and this is the same as this one. So B is the answer. Let's see D में क्या गलती है. Wow, D has given us two methyl groups on the same carbon. That's not a possibility. Look at butanol. It doesn't have any branches. Okay. An ester with odor of banana has the following formula. Which pair of reactants in a suitable condition will produce this ester? So identify where the ester linkage is. It is over here, which means this whole thing comes from alcohol and this thing comes from carboxylic. So this whole thing, which is attached to oxygen, इसको जरा OH group पर पकड़ा दो कहीं पे भी. CH2 के साथ OH group लगाना है. ये नहीं हो सकता. ये नहीं हो सकता. ये हो सकता है. ये हो सकता है. So it's either C or D. And this whole group will get H attached to it. So CH3COOH, ethanoic acid. This one. Pretty easy. Just identify where to break the ester linkage from where the oxygen is. Okay.
Okay, sir.
I would like you to complete the worksheet now. We have what I think total 36 questions. तो 6 तो रह गए, and then there is the optional ones. ये वाले you don't need to attempt them because they are not going to be in your exam, but you can attempt them because they are still harder level of difficulty. So that will really test your abilities. But complete this. Tomorrow we do this worksheet number 2, which is the theory questions. Okay.